Following presentation is about slope-intercept form for linear relationships. Anytime you have a constant rate of change, you have a linear relationship. The slope-intercept form for linear relationships is y equals mx plus b. Y represents the dependent variable, m represents the slope or the constant rate of change, m equals the rise over run on a graph, or you can calculate the slope given 2 points if you have y2 minus y1 over x2 minus x1. X represents the independent variable, and b is the y-intercept on the graph, or the starting point for the relationship. How to graph slope-intercept form. So the first equation we have is y equals 3x minus 4. The y-intercept is 0, negative 4, so we plot that first, negative 4 on the y-axis. Then we use the slope, rise over run. The slope is 3, so we're going to go up 3, to the right 1, and plot the next point. And then we will do this again, go up 3 over 1, plot another point, and connect the points in a straight line. When you draw your linear graphs, you need to draw arrows on the end of a completely straight line. For the next equation, we have y equals negative 2 over 5x plus 3. The y-intercept is 0, 3, so 3 on the y-axis. The slope is negative 2/5, so we're going to go down 2 and to the right 5. Our other option is to go the opposite direction, so we can go up 2 and to the left 5. So up 2 to the left 5. And then we're going to connect our 3 points with a straight line with arrows on the end of the line. Write the equation of a line in standard form that has a slope of negative 1/2 and crosses through the points negative 6, negative 2. So here's slope-intercept form, y equals mx plus b. We are given 2 pieces of information. We're given the slope, so that means m is equal to negative 1/2, and we're given a point, negative 6, negative 2, which means we need to solve for b. So we plug in negative 2 for y, negative 6 for x, and negative 1/2 for the slope. We simplify, and we get a b of negative 5. The equation of a line is y equals negative 1/2 x minus 5. Suppose a balloon begins descending at a rate of 20 feet per minute from an elevation of 1,350 feet. First part of this problem, we're going to write the equation that represents the situation. So we know since we have a constant rate, we can use y equals mx plus b. X is time in minutes, that's our independent variable, and our dependent variable is y, the elevation in feet. We know m, which is the rate, is negative 20 feet per minute. We use negative because we have the word descending. And b, which represents the starting point of our balloon, and that was an elevation of 1,350 feet. To fill in the information into our equation, we get y equals negative 20x plus 1,350. What will the elevation of the balloon be after 30 minutes? Since x equals time, we're going to plug in 30 for where we have x in our equation. And then when we simplify, we get 750. To answer in a complete sentence, the elevation of the balloon after 30 minutes is 750 feet. Don't forget your units when you write your sentence. When will the balloon touch the ground? The balloon will touch the ground when the balloon is at a height of 0. So we are going to plug in 0 for the elevation in feet. And when we solve for x, we get 67.5. To answer in a complete sentence, the balloon will touch the ground in 67.5 minutes.